Good morning, class. Here's Module 4, covering Chapters 8 and 9. Chapter 9, Systems of Linear and Nonlinear Equations. Here's the pledge. Before starting the exam, I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam. Unauthorized actions include but are not limited to the use of notes, text, graphing calculators, search engines, PowerPoints, AI, or any other resources not explicitly allowed. For a portion of this exam, you may use a graphing calculator when it comes to matrices. But having said that, we want to solve this system, again, the good old ways. And so I'm going to give them a name, equations 1, 2, 3. And remember, there are three equations, three variables. So you want to get rid of one of the variables, take it to 2 dimensions, and then get rid of one more. You notice right away that we can add these two because negative 4y and 4y cancel each other. So if I add those two, I end up with 5x, 3z plus 3z equals 1. Now, which one we have not used yet? It's this equation. We must use the equation that hasn't been used, namely equation 3. Which one? Do we use it with the first or second one? Makes no difference whatsoever. Because this has a negative sign, we're going to go with that one. I'm going to multiply this one by 3, this one by 4. This way, they can undo each other. So if I multiply by 3, I get 9x minus 12y plus 6c equals negative 45 over here. 8x, 12y, 20z equals 80. And these two cancel each other. 8 and 9, 17x. 6 and 20, 26c. Negative 45, positive 80 is positive 30. I'm going to put the equation 4 and 5 next to each other. Notice we had 3 variables. Now we went down to 2 variables, and we're going to get rid of one of the variables here. For example, if I want to get rid of the x, I'm going to multiply this one by 17, this one by 5, one of them negative. If I want to get rid of the z, this one by 26, this one by 3, one of them negative. So we are going to multiply the top one by 17, the bottom by negative 5. So as we multiply, we get 85x 51z equals 17. When we multiply negative 5, we get negative 85x minus 130z equals minus 175. And so these two cancel each other. These two give us negative 79z. These two give us negative 158. Divide both sides by negative 79, get positive 2. Z equals 2. Now, we will go back to one of the two equations that have only two variables. For example, equation 4. And we plug in 5 times x plus 3 times 2 equals 1. So 3 times 2 is 6. To take it to the other side, negative adds up with 1 becomes negative 5. Divide by 5 and you get negative 1. So x is negative. Now we're going to go back to one of the original equations that have 3 variables. For example, equation number 1. And we find the last variable, namely x. So 3 times x, 3 times negative 1, minus 4y plus 2 times z2 equals negative 50. So they add up to 1. They move to the other side. So we have minus 4y equals minus 16. Divide and y becomes positive 4. And we have the triplet -1, 4, 2. We must check with number 2 as well as equation number 3, and it literally takes a split second. It doesn't take long. You must check your work. For example, 2 times x, 2 times -1 is -2, 4 times 4 is 16, and -2 is 14, plus 2 is 16. I just checked it, split second. And you do the same thing with the third one. That's why you don't want to take a chance whenever you're dealing with a system. So now, having said that, let's look at this one from the point of view of matrices, starting with the augmented matrix. Remember, you can look at it as a row 3 -4, 2, -15, or column, doesn't matter. Just make sure all the x's are in the same column, y's and z's, and if any of them is missing, takes a 0 as a coefficient. So 3, 2, 2, -4, 4, 3, 2, 1, 5, and the solution, or the constant, -15, 16, 20. So that's the augmented matrix. Now you can put that into a calculator, and because there is not enough room, it doesn't show the fourth column. I'm going to show the 2 of them combined. Please understand, this is the first, second, third column. Then we repeat it here. That's the same one. That's the same one. And this is the new column, the fourth column. Now, REF, and again, there is not enough. I can show you the second piece and change it to fractions. And we get this one. Please understand, this means Z, 1Z equals 2. So it gives you the value of Z. Back substitution will do the answer. So from the augmented matrix, simplified REF, reduce echelon form. For example, x -4 thirds y plus 2 thirds z -5. The second one, y -1 over 20, z equals 39 over 10, and z equals 2. From this augmented matrix, we go to equations and back substitution. Z is 2, put it in here, find y. Both of them, put it in here, find the missing x. If instead of REF, I do RREF, the reduced row echelon form, look at the last column. It's exactly what we had here is the solution. So I hope everybody is clear. And again, this is using the system with matrices. We want to solve this system, and we are going to do it both ways. We are going to do it by hand, and I'm going to show you with matrices and calculators as well. Notice x plus y plus z, we have 3 variables, 2y plus 3z equals -14, -16, y minus 24, z equals -112. We have 2 variables. So we're going to work on these 2. For now, we're going to ignore the first one. And we notice if we multiply this one by 8, we get 16y, we can cancel this one. So let's multiply the second equation by 8, and we get 16y plus 24z minus 112, and we just repeat the third one. So these 2 cancel each other. These 2 cancel each other, we get 0, but these 2, they add up to -224, which is a false statement. So there's no solution. False statement, therefore the solution to this system is an empty set. There is no solution. If I were to do by matrices, I'm going to write the augmented matrix. I'm going to go with the row 1, 1, 1, 14. This one, 0, 2, 3, -14. This one, 0, -16, -24, -112. Okay. In other words, the second one and the third one, they don't have any x's, so 0x. I do REF, or if I do RREF, in both cases, look at the last row. All zeros, except the last one. So that means 0x, 0y, 0z. That means simply 0 equals 1. And that's a false statement. So the corresponding equation for the last row, 0 equals 1, is a false statement. a row of all zeros except the last entry. Therefore, the system is inconsistent, and the solution to this system is an empty set. So that's pretty straightforward, and I hope everybody is okay with that. What about this system? Let's do it by addition or elimination method. We notice if we multiply this one by 3, we get minus 3x and 3x cancel each other. So let's do that, which means we are going to write the second one unchanged. And the first one is minus 3x minus 9y equals minus 6. When we add them up, these two cancel each other. These two cancel each other. These two cancel each other. We get 0 equals 0, which is a true statement. So we are dealing with a dependent system. There are infinitely many solutions. So the way we set up a dependent system, everybody, we pick one of the variables, in this case x, and the rest of them, there happen to be one more, which is only y, based on that. But if there are, let's say, more, y, z, and more based on x. So if you choose x, what is y? So let's solve for y in one of those equations. Doesn't matter, those equations are ultimately the same. So I'm going to move this, and I get negative 3y is positive x minus 2. Then I'm going to divide by negative 3. And that's exactly what we have here. Which means now, when you write it in this format, x comma negative 1/3 x plus 2/3, all you have to do, pick a number for x. And for example, an easy number would be multiples of 3. So if you put 3 here, then you put the 3 here, and you get minus 1 2/3, which is negative 1/3. So all you have to do, pick just one variable, x, even if you have z and you write it in that format. So that's the methodology. So having said that, let's look at the augmented matrix. And let me erase my work. If I go with the row negative 1, negative 3, negative 2, the second row 3, 9, 6. First and foremost, you may notice if I multiply this row by some number, in this case negative 3, I get the second one. So notice that row 2 is negative 3 times row 1. When a row is a multiple of another row, the system is dependent. The two equations are dependent. The two equations are identical in essence. Now, if I do REF, the last row, or RREF, the last row will be all zeros, which means 0x plus 0y equals 0, or simply 0 equals 0, which is a true statement. Therefore, that's what we got here. The corresponding equation for the last row, 0 equals 0, is a true statement, a row of all zeros. Therefore, the system is dependent with infinitely many solutions. Infinitely many solutions. So I hope it's clear to everybody. What happens when we are dealing with nonlinear systems? We work in the same manner. For example, substitution method, addition method, whatever that works. We notice that we can just simply add them up, and the concept of an addition method will do the job for us. These two cancel each other. We get 4x squared equals 28. X squared is 7. X is plus minus square root of 7. We put that into one of the equations, and it's easier to put it in equation number 2. And notice, whether I put positive or negative square root of 7, because I'm squaring it, it doesn't make any difference. Both of them will give me 7. Y squared is 9. Y is plus minus 3. And believe it or not, the way you write this, there are 4 pairs, meaning put negative and positive square root of 7 with negative 3. So minus square root of 7 minus 3, positive square root of 7 minus 3. okay? And then put that with positive 3, and we get those 4 in any order you want. And you have to check. Notice, again, we used equation number 2 to get this. Then we don't need to check with equation number 2. Rather, we must check with this one. And so let's plug in. We're going to plug in one of them, and you really have to check all of them. So we're going to put 3 times parentheses minus square root of 7 quantity squared minus y squared. That means negative 3 quantities. We put that into equation. This to the power of 2 is positive 7 times 3, so 3 times 7. And this one minus, and this one is 9. As you know, this is 21 minus 9 is 12. So that checks. And again, as I mentioned, we did this one, you should really look at the rest of them just to be on the safe side. So having said that, let's look at system of inequalities and their graphs. To do that, let's change each inequality to an equality. 2x minus y less than 2 becomes 2x minus y equals 2. 3x plus 2y larger than or equal to 6 becomes equals also. And this is a simple line. You have to pick up 2 pairs. If I pick x to be 0, it goes away. Y becomes negative 2. If y is 0, x becomes 1. This one, x is 0, y is 3. Y is 0, x is 2. So I'm assuming nobody has any problem finding the intercepts. So having said that, let's start with the top one, 0, negative 2. So now let's go down to here. And 1, 0 here. And connect them. And it has to be a dashed line. Why is it dashed? We go back to the original inequality. Less than. Since it doesn't have an equality, the line, which is called the boundary line, is not included. 0, 3, 1, 2, 3 is there. 2, 0, 1, 2 is there. Connect them, and it's a solid line because 3x plus 2y larger than or equal. So those are the two equations. So we write the equation. Now, how do we check? We pick a test point, any point that doesn't belong to the line. You can even pick a point that belongs to one line, not to the other one, because you're going to separately check them. So how do we check them? We go back to the original inequality, 2x minus y. So 0, 0 is here, and we're going to check that. So 2x minus y, that means 2 times 0 minus 0 is less than 2. Yes, it's a true statement. So right here, for the red line, 0, 0 works, which means you can shade this side. And if you had only one inequality, we would be done. This is the answer, we are done. But we have the second, and so we're going to, again, use the same 0, 0 because it doesn't belong to the blue line. So if I put 0 here, 3 times 0, 2 times 0, I get 0 larger than or equal to 6, which is a false statement. So that means 0, 0 doesn't work for the blue line. So it's the opposite side that we need to shade as the true solution. As you can see, these two intersecting lines create 1, 2, 3, 4 different regions. This is the region that has both lines come together. That's the solution, the red and blue, or this is the way you write it. Either way, this is the final answer. What about graphing an inequality which is non-linear? Same format. First, change it to equality. As you know, y equals x squared is a parabola plus 1 shifts up by 1 unit. So it's an easy graph. This one has coordinates 0. So we should know that. Now, generally speaking, it's either inside or outside. By the way, you don't have an equality, so the boundary curve, which is a parabola, is not included. We will indicate that in a moment. Now we pick a test point. Test point can be 0, 0, can be 0, 2, any point which is not on the curve, and we put it in here. So we replace the y with 2 and x with 0. 2 is larger than 0 plus 1. Yes, that's a true statement. So this works, the entire region inside works, and this is dashed curve. The curve is not included, again, why? Because we don't have the equality here. Okay. And you can, again, pick 0, 0 and check it, or 2, 0 and check it. For example, if 2, 0, 4 plus 1 is 5. So 0 larger than 5, it's a false statement. You see the outside doesn't work. You can try it if you want that. All right, we are dealing with an application problem. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he's got 80% and 40% acid solutions. How many liters of each in stock solution should he mix to get a 10-liter mixture? So this is a classic problem known as a mixture problem. So in the case of a application, always come up with some sort of a table. If it's a mixture problem, if it's a motion problem. So a table helps. So the solution here, strength of solution, volume, pure amount, 80% and 40%. The one that we are mixing are 80% and 40%, okay? And the mixture is 48%. You can leave it as 80% or note the strength just simply becomes 0.8, everybody. And this one, 40%, can leave it or 0.4. And this one is obviously 48% or 0.48. Okay. Now, what do we know about the volume? We want 10 liters of 48%. So 10 goes here, which is the concept of a mixture problem. When you mix things, the total volume remains constant. How much of each do we have? How about X and Y? Because we don't know. Therefore, this gives the equation X plus Y equals 10 liters. Now, the pure amount or the actual amount of acid, if something is 80%, that is the concentration, only 80% of that is pure acid. The rest is not. Normally it's water. So this is 0.8x. This is 0.4y. This is 0.48 times 10, which is 4.8. Gives rise to this equation, x plus y equals 10. To this equation, 0.8x plus 0.4y. First, let's write this one, 0.48 times 10. So you have two equations, two unknowns, and you can do by any method. For example, if I solve for y by moving the x and replace it here, I say 0.8x plus 0.4, replace the y with 10 minus x, and this is obviously 4.8. So this one we keep, this one we distribute, 0.4 times 10. Remember, one decimal, 1 0 cancel each other, we get 4. Minus 0.4x, and the right side is unchanged. So we move things around. First and foremost, we combine these two, and we get 0.4x. This one we subtract 4, and we get 0.8. We divide, and we get 8 over 4, or 2, which means what? X is 2. If X is 2, Y must be 8. We have 2 liters of 80% solution, 8 liters of 40% solution. So very straightforward, everybody. Now, you must check. To check, you have to check it for this one. 0.8 times 2 is 1.6. 0.4 times 8 is 3.2. Do they add up to 4.8? Yes, and you just checked it. I can't emphasize the importance of checking, which really doesn't take long with the other equation. In this case, it's the second equation. You always check accordingly. Very straightforward. Again, a mixture problem. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12%. So again, we have the same table, but one of them is a 15% solution, one of them is a 10% solution, and then we have a mixture. The strength, obviously, this is 0.15, this is 0.1, and the mixture is 12%. But let's take it from the top, and from the get-go, we start with 15%, so that is 0.15. So we continue. Must be mixed with 6 liters containing 10%. So that means the volume of a 10% is given as 6. And now change this to 0.1. To make a mixture of 12%, so 12% of 0.12. So how many liters of 15%? I don't know. How about X amount, X liters? And the idea behind the mixture problem is very simple. This is a constant. The sum is X plus 6. Again, the pure or the actual amount is the product of the strength and the volume. If something is 15% solution, only 15% is pure, the rest is not. 0.15x, 0.1 times 6, 0.12 times x plus 6. So the first one is 0.15x. The second one is 0.1 times 6. And the last one is 0.12 times x plus 6. And this is the equation of interest. In other words, 0.15x plus 0.1 times 6 equals 0.12 times x plus 6. That's the equation. And so this is obviously itself. This one is 0.6. This is 0.12x. 6 times 12 is 72. You have two decimals. 0.72. So let's distribute and simplify and take it from there. Obviously, we move this. And subtract it from 0.15, we get 0.03x. We move this. We get 0.12. And we get 4, therefore 4 liters of 15% solution. That's pretty straightforward, everybody. So I hope everybody's okay with that. A plane can travel 800 miles per hour with the wind and 720 miles per hour against. Find the speed of the wind and the speed of the plane in still air. Set up a system of equations. First and foremost, I can represent them with x, y, z, and so forth, but I'm going to go with the initial. Therefore, I'm going to say the plane has a speed P miles per hour. The wind has the speed W miles per hour. For me, it makes it easier to remember that way. And so we start with that. The next thing is when we are going in the same direction as the wind, whether we are dealing with riding a bike, driving a car, or an airplane, in the same direction, it will help us. If you're swimming, the speed of the current will help you in the same direction. On the other hand, if you are going the opposite direction, it works against you. And that's important to understand. So having said that, this means the sum of the two is 800, P plus W. And this means P minus W is 720. By the way, why P minus W? Of course, the speed of the plane is much more, otherwise it's not moving in the first place. So we can clearly see these two cancel each other. We get 2P equals 15 to me. Division by 2, P 760 miles per hour. So if the plane is doing 760 miles per hour, this must be plus what number to give us 840 miles per hour. And you can clearly check it with this one. It doesn't take long. It's a split second. And we're done. Very straightforward, everybody. All right, we are going to move on. All right, let's read this question and see what's going on here. Admission tickets to a Little League All-Star game cost $4 for adults, $1.50 for children. A total of 225 tickets were sold, and a total of 500 was collected from ticket sales. How many adult tickets and how many children tickets were sold? We want to set up a system. Obviously, we start with the table, and believe it or not, this is also a mixture problem. So we have adults, we have children, we have total tickets cost, number, total amount we collect in dollar. So what is the ticket cost? Well, $4 for adults, $1.50 for children. Okay, so a total of 225 tickets. This number represents the number of tickets. How many total? 225. And we are collecting total of $500. Total amount, $500. Now, how many adults, how many children? I can go with X and Y, but I like to go with the initial again. Sometimes it's a lot easier because you won't have to even define it. A stands for adults, C stands for the children. And clearly this is one equation, A plus C is 225. But how much do we collect from adults? 4 times A. From children, 1.5 times C. And that's, so this is the first equation. This is the second equation. So this one, A plus C is 225. This one, 4A plus 1.5 C is 500. Now you can use any method to solve it. For example, we can get rid of the A because it's 1.5. We don't want to deal with that. So we're going to multiply this one by -4. And if I do that, I get -4. First of all, the second equation, we just write. The first one, -4A minus 4C, and -4 times 225 is -900. So the second one, we keep it intact. These two cancel each other. This is negative 2.5C. This is negative 400. So that's the same as negative cancels out the negative 4,000 over 25. I hope you see this is 100 divided by 25 is 4 times 40 is 160. And if C, the number of children, is 160, the rest of them, 225 minus 160 or 65, must be the number of adults. Very straightforward, everybody. One leg of a right triangle is 4 centimeters less than the other one. The area is 70 square centimeters. Determine the length of each leg, set up a system, and solve. Obviously, what is a right triangle? Looking like this. And we define the legs as X and Y, which means clearly it says one is 4 centimeters less than the other one. X is smaller. So X is Y minus 4, or Y is X plus 4. It doesn't matter. The other one is that the area is 70 square centimeters. So area is 1/2 base times the height. And in the case of a right triangle, the legs, one of them is the base, one of them is the height. So as I mentioned, X is Y minus 4. Half of base times the height, XY is 7. That's it. This is the system. Now, how do you solve that? First, let's get rid of the fraction. Let's multiply by 2, everybody. And so this becomes XY equals 140. Now let's do substitution. Let's put the X in here and change it to Y minus 4. So this is Y squared minus 4Y. And since we want to factor, we're going to move the 140, becomes negative on the left side. We want two numbers. The product is negative 140. The sum is negative 4. So the answers are negative 14, positive 14, negative 10. So negative 14, 10, and the answer becomes Y equals positive 14, negative 10, and we can have a side that is negative. Y equals 14 is the answer. We go back up here, and we say if Y is 14, minus 4 is 10, X is 10. And we check it, see, half of X times Y. If I multiply this two, I get 140. Half of it is 70. So it takes a split second to check. And that's the beauty of math. You can always check your